So this is our homepage of the front-end asset management system. So this page contains theme in both light mode and dark mode. Uh, Here we have stored the information about the assets in numerical as well as graphical way, like total assets, assigned assets, pending approvals, and maintenance, how many are there in maintenance. Here we can get monthly data, how many are assigned, how many are returned, and here is the chart where we can get the department wise data, from which department how many assets are taken. So let's move to the catalog. Here we can request for any asset. We can bifurcate by, filter out by categories, and also by in stock, out of stock, and availability. For making any request, we can just here tap request and submit it. This request will be goes to the inbox. Now next section is assets. Here the information of assets which are available, which are assigned to whom, and which are retired means they are dead. Next is bookings. Here's the booking table for the future schedule. Next is maintenance. Here we can also get the assets through their status, like assigned, in progress means in approval phase, waiting parts, resolved. And here we can see the history, which asset is assigned to whom, and its previous assignment. Here the details of the employees are there. By employees, how many assets they hold. There is a report for annual, month, maintenance trend key, in which month how many are gone under maintenance, so we can get the quality of the assets and their improvement. Utilization by department. Finally is our inbox. Inbox we get all the requests, like replacement, which are under new request, which we have to approve. So that's it. This was our front end part.
Okay, so this is the backend of our project Asset Flow, an enterprise asset management system. Now the backend is built using Node.js, Express.js, Prisma ORM, and PostgreSQL. I will now demonstrate the server database and how API interact with it. So this is our project backend organized into routes, services, middleware, and Prisma model. The database schema is defined in schema.prisma, and Prisma generate the client automatically. So here are our important entities, main entities in our system, that is department, employees, asset, allocation, booking, maintenance, notification, audit logs, and that's it. Now let's start our backend. npm run. Now the backend server is running successfully on port 3001. Let's open it. Let's check the API. Endpoint confirms that our backend is running correctly. Now let's see the Prisma Studio database, in which it contains tables of employees, department, asset, allocation, and booking. Contains all the database for the project here. This is the PostgreSQL database. These are the seeded user, included admin, manager, and staff account. So here are the details of the assets which required in the organizations, and then department details, employees details, audit logs, notifications, and all the tables are here, in which we use Post. To summarize, our backend provides secure authentication, asset management, booking, allocation, maintenance tracking, and notification and audit logs. Prisma manages the database layer, while PostgreSQL stores all application data reliably. Thank you.
Hello judges, myself Ashwin Lulla from the team Null Pointer. My role in this project was developing an AI-powered RAG module for Asset Flow, we wanted users to ask questions about company policies, SOPs, company handbooks, FAQs, and other internal documents using natural language, and that all PDFs are uploaded in this uploads folder. And the workflow is very simple. First of all the PDFs are uploaded in this and are splitted into smaller and are converted into LangChain documents by using LangChain document loader such as PyPDF loader, and then they are splitted into smaller chunks using this text splitter, recursive character text splitter. And these embeddings are given to a embedding model, which is Google Generative AI embedding. And then these are stored in a vector database. Here we have used ChromaDB for storing the vectors. And so when the user asks a question, the system performs a semantic search to retrieve the most relevant document chunks. These are then provided as context to Gemini model, which generates an accurate answer based on the retrieved information, and that retrieval is stored in this retriever folder. Finally, the system returns both the answer and the documents in the front end, making the responses transparent and trustworthy. The architecture is modular, so while we were using ChromaDB for the hackathon, it can easily be migrated to PostgreSQL with pgvector for production use. Let me show you a demo for this. As you can see, the answer is uploaded by the Gemini model based on the documents we have given it to it.